Hello everyone, welcome back to Deeksha Karnataka YouTube channel. Today I am going to discuss the top 30 questions from the chapter Current Electricity. This is the most important chapter of your second PU. 6 to 7 question comes from this chapter. I have already done one short video in the Master Stroke series. If you have not watched that, go and check that out. The link of that is given in our channel Master Stroke playlist. You can go and check that out. Now let's start without any delay about this chapter. First of all, some questions are some portions of this chapter are deleted. I have seen a lot of students are still confused about whether the color code combination is there or not. Color code is not there. Okay, potentiometer, meter bridge, they are not there in your syllabus. So if you are solving questions based on these concepts, you can ignore those concepts. They are not going to come in your KCET exam. Be assured, if they are coming, they will be considered to be out of syllabus question and they will be deleted. So don't waste time on those questions. Let's start with the first question. For a given electric current, the drift velocity of conduction electron in a copper wire is Vd and their mobility is mu. When the current is increased at constant temperature, Vd remains the same, mu increases, Vd decreases, mu remains the same, Vd remains the same, mu decreases, Vd increases, mu remains the same. Now, first of all, you have to understand that the mobility is dependent on, even though it is drift velocity per unit electric field. If you are increasing current, you are changing the electric field as well. So mu remains constant. Mu will only change on temperature. Okay, it depends on the collision time. Tau directly proportional. Okay, it depends on the mass of the electron. It depends on the charge of the electron. Now charge and mass are constant, so only depends on the collision time tau. Now that tau depends on the temperature, so mu will remain constant for sure. What about Vd? We know that I is equal to NEA Vd. Now if you increase I, so Vd equals to I by NEA. So if you increase I, Vd will increase directly proportional. Vd, drift velocity and current are directly proportional. So if you increase I, Vd will increase, but mu will remain the same. So Vd increases, mu remains the same. Option D is correct answer for this question. So be careful. Okay. Now next question, 10 identical cells, each EMF 2 volts and internal resistance 1 ohm are connected in series with 2 cells wrongly connected. Okay, a resistor of 10 ohm is connected to the combination. What is the current through the resistor? So we have how many cells? We have 10 cells. Okay, 10 cells are connected in series. So 10 cells, suppose this is how it's supposed to be connected, but in between 2 cells are connected wrong. 2 cells connected wrong means they are connected in the opposite polarity, okay, compared to the rest of the cells. So I am not drawing all the cells. Now each of them has 1 ohm internal resistance. 1 ohm internal resistance is in between them. So what is the total resistance? 10 ohm is the resistance of the external resistor, and the total resistance will be 10 plus 1 ohm into 10, that is 20 ohm. 20 ohm is the total resistance. So each of them are connected in series. No matter how the cells are connected, the internal resistances will always be added. Okay, so resistance always gets added. So resistances will be 1 into 10, that is 20 ohm. Now what is the total EMF? Total EMF will be they supposed to be connected 10 cells in series, but 2 of them are connected in the opposite polarity. Wrongly connected means they are connected in the opposite polarity. So what is the how many of them are connected properly? So 10 minus 2, that is 8 of them are connected properly. Okay, but 2 of them are connected in the opposite polarity as well. So you have to do this, and each of them are of 2 volts. So total EMF is this. This 2 is the 2 volt, and 8 of them connected properly, 2 of them are wrongly connected. So 12 volt is the EMF. So what is the current? Current is equal to EMF, total EMF divided by total resistance, that is 12 divided by 20, that is 0.6 ampere. So 0.6 ampere is the answer for this question. Now next question. The equivalent resistance between the points A and B in the following circuit. So this is a very common type of question where you get an infinite circuit. Okay, this is called an infinite circuit, but if you see that they are very symmetrical. Okay, why I am saying symmetrical? Suppose I cut this circuit from here. If I cut this circuit from here and I remove this part, you will see that this portion from here onwards looks exactly like if you are looking from here. Okay, so this portion, if you ignore this portion, then this portion looks exactly like the portion from here. Okay, this is the beauty of infinite symmetrical circuit, right? So basically what we can say, that if the equivalent resistance of the entire circuit is equals to say small r, then equivalent resistance of this portion of the circuit, which exactly same as the original circuit, okay, they will also have the equivalent resistance of small r. That is the important part you have to understand. Okay, so you have, in your mind you have to consider that, okay, this part is not there, then you have to identify the line from where it is symmetrical. So this is the line from where everything on the right hand side is exactly same if you start from A and B. Okay, if I say this point is A, this point is B, then also it is same, right? So the equivalent resistance from this for this part is also R. This is the technique to solve this question. Now we will redraw this circuit once more. Point A, 2 ohm is here, then we have one more 2 ohm is here, and this portion we have cut, right? This portion we have cut it from here, and we said that whatever is left, that is the same resistance as the original circuit. So original circuit resistance we assumed small r, so this portion will also have small r, rest of them 2 to 2. Now this one will also have equivalent resistance equals to small r, that was our assumption at the beginning. So we will find the equivalent resistance for this portion and we will equate it to small r and calculate the r value. So this is 2 ohm, this is 2 ohm, they are connected in series. In between, this portion is connected in parallel. So 2 and r are connected in parallel, so 2 into r divided by 2 plus r, right? Two resistances connected in parallel, this is the formula for that, right? We will use lot of shortcuts here because otherwise the problem is very long. Now that entire this resistance, this equivalent resistance, or whatever we have calculated there, they are all connected in series. So plus 2 and that is equals to r, right? Now what we have to do, we have to take this portion on the other side. So 2r divided by 2 plus r equals to r minus 4. Right, now there will be a quadratic equation, we have to take the positive value, so solve it. 2r equals to 2r minus 8 plus r square minus 4r. Okay, just multiply these two terms, you have to multiply these two terms, there is no other way. Now you can cancel these 2r, both are positive. Now you have to simplify this. So what you got? You got r square minus 4r minus 8 equals to 0. Now can we solve this equation anyhow? Okay, this 8 cannot be divided into anyhow to make it 2 fourths. Okay, not possible. So what we have to do, you have to apply the quadratic equation formula. So what is the quadratic equation formula? That r equals to so we will use the Sridharacharyya formula or quadratic equation formula, whatever you call it, minus b plus minus square root of b square minus 4ac divided by 2a. So you will use that formula. So what is b here? B here is minus 4. So minus b means minus 4 of minus 4 plus and minus. Obviously, remember that we will only take the positive value, negative value we will not take. Anyway, let's see what is the value of this. It will be b square is 4 square, that is 16 minus 4ac, 4 into 1 into minus 8. Okay, obviously it is coming more, so we will not consider the negative value here. We will only consider the positive value 2a, that is only 2 into 1. Okay, now minus plus 4, plus value, as I said, we will consider only the plus value. So 16 plus 32 is 48 divided by 2. Now this is not exactly squareable. You can take the square root of 48, which will come, I think, as 4 root 3, but we are not doing that. What we will do, we are smart, we will not fall for that trap. What we will assume that this 48 is exactly equals to 49. In our head, we will consider this 48 to be 49. So we know that 49 square is 7. So 4 plus 7 by 2. So it is 11 by 2. That is 5.5 ohm. Okay. So this is the value, and according to the given answer, we can see that 5.5 ohm is the answer. Okay. Now based on this values 2 ohm or 3 ohm or 5 ohm or 4 ohm, this result will change. Okay, this result will change, but if you know how to solve it, you can solve it easily. Now let's move on to the next question. Okay, so if you are preparing for KCET 2025, obviously you know that we have launched Abhyas KCET test series, which is live. Currently we are into the phase of part tests, so that our syllabus are going to be completed. So I think physics part test is coming very soon, last part test. Then onwards we will be having full length test, that is according exactly KCET like papers will be given to you, and you can practice your time management through that test series. Okay, it will be app-based test series. It is app-based test series where you are getting all the questions. You can answer them within the duration of 60 minutes, so that you are fully prepared for your KCET exam. Right, so I hope to help you with your KCET 2025 preparation, Abhyas will be a very great tool. It will not only give you the idea what type of questions you can expect, but also it will give you an perfect platform for practicing for your KCET 2025 exam. A lot of students are already registered with KCET Abhyas KCET test series. So if you are not one of them, then don't wait today. Join via link given in the description of this video. Now let's move on to the next question. So this is a very common question, common type of question. I think I took this question from 2024 paper, but this type of questions also came in the past as well. So as soon as you see this kind of structure, okay, so one resistor, then one resistor connected like that, another resistor connected like that, you should know that this is nothing but a Wheatstone bridge. So if you draw this circuit like this, if you redraw this like this, okay, circuit, you just need to redraw this circuit diagram. Okay, this resistance will be like this resistance will be this one, this is the central resistance, and this one is from here to here, and this one is from here to here. So as you can see, all of them are connected according to Wheatstone bridge. Okay, all other way you can just imagine that you just pull them like that, so that you get the Wheatstone bridge structure. So Wheatstone bridge structure, as you see, these resistances are in combination R by R, and this is also R by R. So R by R means P by Q is equal to R by S. So both of them are in the balanced condition. So in the balanced condition of Wheatstone bridge, what we know that these resistances are there is no current passing through the central galvanometer. So central galvanometer, no current passes through, means you can simply erase it, right? So first we will find the resistance of this part. With the similar logic, we will say that this is also a part of Wheatstone bridge, so there will be no current through this resistance as well. We just simply erase it. Okay, if you just erase it, how can I erase it? I can erase it using this. If you can simply erase these resistors, you will see that basically there are these two resistance and these two resistance, and they are connected in, first two resistances are connected in series, then they are connected, the combination of series are connected in parallel, right? You can see that. Similarly, you can do this for here as well. So these resistances are basically given as false, okay, because it's a Wheatstone bridge. So that means these resistances play no part in the actual equivalent resistance calculation or even current calculation, okay. So first we will calculate the equivalent resistance of this combination. So R plus R is 2R, okay. So R plus R is 2R, again another R and R, they are also series 2R. What is the equivalent resistance of 2R and 2R in parallel? So equivalent resistance of 2Rs in parallel is equals to R. So this entire resistance of this, the entire resistance of this part of the circuit is basically R, right? Now if this is R, then now tell me what is the value of this. So if this is R, this entire portion is R, that means this entire portion will be 2R. This entire portion will be 2R. Okay, same logic, 2R, 2R series, 4R, again 4R, 4R and 4R are in parallel. So 4R by 2, that is 2R. Okay, so what is the total resistance of the circuit? Total resistance of the circuit R plus 2R, that is equals to 3R. So 3R is the total resistance. So what is the current? Current in the circuit is I is equal to V by total resistance 3R. So total resistance is V by 3R. So V by 3R is the correct answer for this question. Okay, now next question. E is the electric field inside a conductor whose material has conductivity sigma and resistivity rho. The current density inside the conductor is J. The corresponding Ohm's law is. So what is so this is an easy question. We know that what is the relation? J equals to sigma E. J equals to sigma E, right? Now is this relationship given? See, if you see, none of the relationship actually talks about J is equal to sigma E. So what can be other formula? So E equals to J by sigma. Now what is 1 by sigma? 1 by sigma is resistivity rho. So E is equal to rho J. So E is equal to rho J is the correct form of Ohm's law. This is the alternate forms of Ohm's law, right? We have derived that in our P1 exam, P2 exam. Right, so this is the alternate form of Ohm's law. Next question. A wire of resistance R is connected across a cell of EMF epsilon and the internal resistance R. The current through the circuit is I. In time t, the work done by the battery to establish the current I is. So very interesting question, easy question, even though the language of the question seems little tricky. So wire of resistance R is connected across a cell. Okay, so resistance R connected across a cell of EMF epsilon, internal resistance small r. Current in the circuit is I. Current in the circuit is I. Now what is the power of a circuit? Power of a circuit is basically not power, work converted. Okay, so power times time is the work done. Okay, power is power. There are a lot of different formulas, but here we will use I square R. Okay, so the work done is power into time, that is I square RT. You can remember it as Joule's law of heating, the same formula for work done. So now in this formula, why we are using in this formula? Because this formula current is given directly, right? Current is given to us. Other than that, epsilon will not come in this formula, because for epsilon to work you have to first find the current. That current will be epsilon divided by R plus R. So that will be complicated, and then you have to calculate the effective potential, but that is not required here. You can directly use I square RT formula, because I square RT is given in the option as well. So if the current is given, no matter whatever circuit is given, it will be always I square RT. Okay, resistance is given, current is given, you don't need anything extra. Okay, now next question. 10 identical cells, each of potential E and internal resistance R, are connected in series to form a closed circuit. An ideal voltmeter connected across 3 cells will read. Okay, So first we have, let us understand the problem. This is slightly different than the problem we have solved. So here we have 10 identical cells and they are connected in series, and then they formed a closed loop. Okay, so they formed a closed loop. So each of them say epsilon EMF E and internal resistance R. Okay, so what is the total EMF of the circuit? Total EMF of the circuit is basically 10 into E, that is 10E is the total EMF, right? And what is the total resistance of, no external resistance is connected, right? So what is the total resistance of the circuit? 10 times small r. This is the total internal resistance, total resistance of the circuit. So what is the current in the circuit? So current in the circuit is total EMF divided by total resistance, that is 10E divided by 10R. Okay, so it will be E by R. Now it is said that you have taken one voltmeter, ideal voltmeter, and you connected it across 3 cells. Okay, you have connected it across 3 cells. So you have taken the voltmeter and you have connected it across 3 cells. There are other cells as well. So what is the reading of this voltage? This is very easy question. You can easily answer it logically, but I feel that you should know the mathematics as well. So here R. What is the resistance covered in this circuit? Resistance is, total resistance of this part is 3R. Okay, so resistance of this part is 3R. So what is the voltage drop of this part? So voltage drop of this part is I into the resistance, that is I is E by small r and times 3R. So R cancels, you get 3. So 3E is the voltage drop across these 3 cells as expected, but be careful, there is an option less than 3. You might think that the cells has some internal resistance, so the expected value should be slightly less than 3. Actually not, it is exactly equals to 3. Okay, so this option and this option are confusing. So if you are confused, you have to know that if this voltmeter is ideal, you get exactly the same voltage, does not matter what is the total internal resistance of the cells. Next question, an atom, electron revolve around in an atom, comma, an electron revolve around the nucleus along a path of radius 0.72 angstrom, making 9.4 into 10 to the power of 8 revolutions per second. The equivalent current is, so you have to find the current. Now radius is not important here. Okay, radius is not required in this case. So this is, they have tried to make it little complicated by making it with atoms chapter, but anyway this is not atoms chapter question. So they are making 9.4 into 10 to the power of 18 revolutions per second. Okay, so 9.4 into 10 to the power of 18 revolutions per second. So an electron is rotating like that. Now what is the definition of current? Definition of current is I is equal to Q into T. That's it. Now in one revolution, what is the charge flowing? E charge. If the electron is rotating only once, that means only E amount of charge is flowing. Now if it is rotating this many times, what is the total charge? So total charge will be E into the revolution time, that is 9.4 into 10 to the power of 18. This is the charge. Okay, so this is happening in 1 second. So T is equal to 1 second. So basically I is equals to Q only. So you need to just find this Q. So what is E? E is 1.6 into 10 to the power of minus 19 and into 9.4 into 10 to the power of 18. Okay, so it will be 1.6 into 9.4 into 10 to the power of minus 1. Now for the simplicity, what you can consider is that we have to do the mathematics anyway. 9, because if I do the approximation, all the options are very close. Okay, all the options are very close. So it will be less than 1.6, no doubt about it. So either 1.4 or 1.5 or 1.2 is the answer. Let's check. So 1.6 into 9.4 we have to multiply. So it will be 1.4 ampere. Okay, it will be 1.4 ampere. Okay, 1.5, 1.4. So if the results are valuations are very close, do not try to do the approximate method. Okay, if the result was very far off, so for example one is 1.4, another one is 2.5, another one is 6.6, like that, then what you could have done, you could have taken this 9.4 to be 10. Okay, and your approximate answer will be 1.6 ampere. Okay, this 10 to the power of minus 1 and this 10 to the 10 will cancel each other. So your answer would be close to 1.6. It should be less than 1.6. So from there you can guess whichever is the closest answer. But that process is not applicable over here, because it will be either 1.5 or 1.4. Okay, both of them are less. Now you cannot exactly guess what is the correct answer. Mostly if you do it by this shortcut method, you will feel that 1.5 will be correct answer. Actually that is not. It will be 1.4 which is correct answer. So this method, in this problem, the shortcut method is not applicable. Now next question. When metal conductor connected to a left gap of a meter bridge. Okay, meter bridge is not part of your syllabus. Sorry, this question is left. I could not delete it. So meter bridge is not part of your syllabus. You need not to solve it. A charged particle is moving in a electric field of 3 into 10 to the power of minus 10 volt per meter with mobility 1.5 into 10 to the power of 6 meter square per volt second. Its drift velocity is. So mobility is defined by drift velocity divided by electric field. Okay, this is another definition. Okay, now electric field is given and mobility is both are given, so we can directly write drift velocity is equals to mu into E. So mu is given here 2.5 into 10 to the power of 6, and electric field is given 3 into 10 to the power of minus 10. So it will be 7.5 into 10 to the power of minus 4 meter per second. Okay, 7.5 into 10 to the power of minus 4 meter per second is the answer. Now, wire bound resistors are made by winding the wires of an alloy of germanium, gold or gallium. They are very highly conductive. Okay, winding wires of an alloy copper, aluminium, silver, they are also very conductive. Winding the wires of alloy of manganese, constant, tan and nichrome, this is the answer. Winding the wires of any alloy of silicon, Tu and Fe. Silicon is semiconductor, so you cannot create resistor using it. So wire resistor is basically the one you have seen in your laboratory for experiments. Okay, so there was some wire like this. Now how they are made? Okay, you have a rheostat. They are also called, sometimes they are also called rheostat. Okay, and you just rotate it and you measure the resistance, you change the resistance. Now if you think what are the material of this rheostat, they are basically either manganese or constant tan or nichrome. They are all highly resistive and high temperature resistant material. Their resistance does not change with temperature. That is the main reason that they are used as wire based resistors. Okay. So if the resistance changes or it has very low resistance, you need, for example, if you want to use the same resistance using a silver wire. So silver wire, then the length will be very high, 1 kilometer long wiring is required to achieve the same resistance, which is absurd, right? So 1 kilometer long silver, people will steal it. That is why high resistance but low temperature coefficient are expected. So let's see question number 12. If voltage across a bulb rated 220 volt 100 watt drops by 25% of its rated value, the percentage of the rated value by which the power would decreases. So here power rating of the bulb is given, initial power rating 220 volt and 100 volt is given, 100 watt is given, and you are also given that the power drops by voltage drops by 2.2%. Okay, so first we have to write the relationship between power and voltage. Power equals to V square by R. Now there is another formula, P is equal to VI. Now why we are not using that formula? Because if you change the voltage, current will also change. So that way we are not sure which one is constant. But in this case, because we are given an incandescent bulb, for a bulb the resistance of the bulb is constant. So this is a constant. Only P and V, they are directly related through this formula. Okay, now what is the meaning of drops by 2.5%? Means percentage change is 2.5%. What is the meaning of percentage change? Percentage change in voltage is basically this is the percentage change. Okay, if you take the change and if you divide it by the initial value and if you multiply by 100%, you get the percentage change. Okay, so basically what we have to do, first we have to differentiate both sides. So differentiating both sides, we get dP equals to 2V dV by R. Why? R is constant, so that is why we are getting this formula. Now this is not yet done. Now what we will do, we will divide both sides by P. If I divide this side by P, I can divide this side by V square by R. Why? Because P equals to V square by R, right? So from here we get dP by P equals to dV, 2dV by V. Okay, now if I multiply 100% in both sides, we will get the percentage change. So percentage change in dP by P, that is percentage change in the power, is basically 2 times 2.5%, that is 5%. This is the percentage change in the power. So 5% change is in the power. Okay, so be careful. Even though the question looks difficult, this is tricky question. Okay, question looks if you try to solve it in a normal method, it will be very long and very tedious. This is the shortcut way to solve this question. Okay, now next question. A wire of a certain material is stretched slowly by 10%. Its new resistance and specific resistance becomes respectively. So the wire stretched slowly. Now new length is 10. You increased by 10%. So increased by 10%. I gave you a formula that the new resistance is basically what is the initial value? 1 plus how much percentage it changed divided by 100, okay, into nothing into in square, okay, into the original value. Okay, so this is the formula. So basically 1 plus 0.1 whole square into R if it is only about length. Okay, and if you are changing the length, you have to remember that the area is also changing, and based on that this formula can be proven. But this is the thing that you have to remember to solve it in quickly. Okay, so 1.1 whole square into R, that is 1.21 R. So this is it will be 1.21 times, and specific resistance will remain constant. Specific resistance will remain constant no matter whatever is the length or whatever is the area. A wire of resistance 3 ohm is stretched to twice its original length. The resistance of the new wire will be. So as I said, resistance was 3 ohm. This is the initial value. Now you have increased its length to twice. Okay, so the new resistance, twice means what? Twice means 100% increase. Twice means 100% increase. Thrice means 200% increase. Okay, in this case you can simply use twice because it is already mentioned twice. So 2 square is fine. So 4 into 3, that is 12 ohm. Okay, so this kind of questions you should be very careful and you can solve it quickly. This is the shortcut formula. If it is given in percentage, you have to do it 1 plus percentage value divided by 100 whole square into R. If it is given twice, thrice, 5 times, 6 times, 10 times, then that times square into the original resistance. That is the shortcut method to solve these questions. Okay, other than that, if you try to solve it in regular method, it will take some time. Now this is, I think this question is out of syllabus. I am not going to solve it. A copper wire of length 1 meter and uniform cross-sectional area 5 into 10 to the power of minus 7 meter square carries a current of 1 ampere. Assuming there are 8 into 10 to the power of 28 free electrons per meter cube in copper, how long an electron take to drift from one end of the wire to other end? Okay, so the length of the copper wire is given 1 meter. So basically here we have a rod, electron starts drifts from here. Okay, and how long it will take to cover this 1 meter distance. So basically it's a distance time problem. Okay, it is a distance time problem. Only thing is that first you have to calculate the drift velocity. For that we will use our old good friend formula, I is equal to NEA VD, or VD equals to I by NEA. Now all the values are given here, right? So VD, what is the value of VD? I is given 1 ampere. Okay, N is given 8 into 10 to the power of 28. E value you know, 1.6 into 10 to the power of minus 19, and area is given 5 into 10 to the power of minus 7. So all the given values are given in SI units, so no need to convert it in unit as well. So now you have to solve it. 5 into 1.6 is 8, so that is also a whole number. So we get 1 by 8 into 8 into 10 to the power of 28. So plus 28, then we have minus 19, and we have minus 7. Okay, minus 19 minus 7. So it will be 26 plus 28, so it will be 2. So it will be 10 to the power of plus 2. 10 to the power of plus 2. So it will be 1 by 8 is the 64, 64 00 64. Okay, 1 by 64. You don't need to solve it because they don't ask you to, they have not asked you to find the drift velocity, they asked you to find the time taken. Okay, time taken to reach from one end to other end. One end means this is entire length is 1 meter. So basically you can now consider an electron is basically like a car. Okay, electron is like a car, and the velocity of the car is 1 by 6400 meter per second. Okay, so this is the electron which is moving, and the displacement is 1 meter. Okay, how much time it will take to cover that distance? So S equals to Vt, or T equals to S by V. S is 1 meter, and here obviously it is drift velocity. S is 1 meter, 1 meter is the length, and the drift velocity is 1 by 6400, so you get 6400 seconds. Okay, 6400 seconds, or you can write it as 6.4 into 10 to the power of 3 seconds. Correct answer is option D. Now next question. A metal rod of length 10 centimeter and rectangular cross section of 1 centimeter into half centimeter is connected to a battery across opposite faces. The resistance will be maximum when the battery is connected across 10 centimeter into 1 centimeter faces, same irrespective of the three faces. Maximum when the battery is connected across 1 centimeter into half centimeters faces, maximum. So we have to find the resistance when it is maximum. So let's see what is the structure they have mentioned. A metal rod of length. So length is given 10 centimeter. Length is fixed. Now rectangular cross section of 1 centimeter into half centimeter. So rectangular cross section, so basically that means it has a rectangle like this. Okay, so obviously this is how the rod is consists of. Now so this is half centimeter and this is 1 centimeter. Okay, now how you can connect the battery so that resistance is maximum. So resistance will be maximum when the length is maximum, but the area is minimum. So minimum area, which one is the minimum area over here? Minimum area is either this face or this face. These two faces are minimum areas. Okay, and if you connect the battery like this will also give you the highest length. Okay, so if the battery is connected across the faces of half centimeter times 1 centimeter. Okay, half centimeter times 1 centimeter. Okay, connected across 1 centimeter and half centimeter faces. Okay, so this is the point where you will see that maximum length and minimum area, because the resistance is given by rho L by A. So if you want maximum resistance, you need minimum area, maximum length. This is the case where you will get the answer. Now, next question. A car has a fresh storage battery of EMF 12 volt and internal resistance of 2 into 10 to the power of minus 2 ohm. If the starter motor draws a current of 8 ampere, then the terminal voltage of the starter is on is. So what is the EMF? EMF is 12 volt, and what is the resistance? Internal resistance is 2 into 10 to the power of minus 2. So what is the current? Current is 80 ampere. So what is the terminal voltage? Terminal voltage is EMF minus I into R. So EMF is 12 minus I is 80 ampere. Small r is 2 into 10 to the power of minus 2. So it will be 160 divided by 100, that is 1.6. So it will be 10.4 volts. So correct answer is option A, 10.4 volt. Next question. Now this is a very common question. Okay, if you remember the answer, very good. If you don't remember, let's solve it. So first of all, suppose the I current is flowing in the circuit. The problem can be solved in the diagram itself. Right now at this junction, it is getting 3 equal resistance part. We call it equiresistive paths. Okay, so from here to here, the minimum resistance that you suffer is always the same. Okay, 3 resistors, minimum 3 resistors, that is the minimum path. Okay, we call it minimum path. So minimum path resistance is same. So these 3 are equiresistive path. So equiresistive path means current will be divided into 3 equal parts. So let's start saying that this current is, say, 3I. The input current is 3I. Now from the Kirchhoff's current law, we will say that the current will be divided into equal parts. So I and I. Okay, so these 3 paths, all of them are getting equal current, that is I and I. Now after reaching at this point, it is getting 2 equiresistive path, that is 2 resistor from here or here. So again the current will be divided into 2 equal parts. So it will be I by 2, this will be I by 2. Okay, now from here, once the current reaches here, some currents are coming from this side, some current are coming from this side, and it is reaching over here. So same here as well. So now this path, total current output should be 3I, right? Same 3I current is coming from this side, so same current should go out as well, right? So from there, the same logic we can apply that, okay, 3I current will come through this all three resistances as well. Now you have to take any one of the paths. Suppose the voltage of A is VA, voltage of B is VB. Now current is flowing from A to B, so definitely VA is greater than VB. So we can say that from Kirchhoff's voltage law, VA minus VB equals to, suppose each of the resistance is capital R. We are doing the general form first. So each of them is capital R. Okay, now if we apply the Kirchhoff's voltage law across this loop, okay, any one of the loop you can take. We are taking this loop, right? If we take this loop, what is the resistance R, what is the current I? So IR. Then next this one, R into I by 2, and then the last one again R into I. Okay, so this should be equals to the potential difference applied, right? So from here we get, it will be IR 2IR plus, so it will be 5IR by 2, right? So this is the voltage difference. Now you have to find the current I. So I will be equals to or what we are trying to find, we are trying to find the equivalent resistance. Don't worry, we will find it. So I equals to VA minus VB into 2 divided by 5R. Okay, so this is the I. Now what is the actual current? Actual current was 3I. So what is the value of 3I? 3I equals to 6 into VA minus VB divided by 5R, right? I think I made some mistake over here. No, fine. Now what is resistance? Resistance, equivalent resistance should be given by V by R, or VA minus VB divided by the current, right? V by I is the resistance, right? So we have to find this value. So VA minus VB by 3I will be equals to 5 by 6 into R. Okay, now what is the value of R over here? Value of R is given here 1 ohm. So it will be basically 5 by 6 into 1, that is 5 by 6 ohm. Now if you remember that no matter how whatever value is given, if it is a cubical system like this, okay, the value will be always 5.6 times the value of one single resistance. Always remember that 5 by 6 ohm. If it is a 2 ohm system, then 5 by 6 into 2, that will be 5 by 3. If it is a 5 ohm system or 6 ohm system, rather it will be 5 ohm. Okay, so this problem can come in various different values of R. So based on the values of R, it will be always 5.6 times the resistance, right? Now next question, question number 20. IV characteristics of a copper wire of length L and area of cross section A is shown in the figure. The slope of the curve becomes less if area of the wire is increased, less if, so first of all, okay, before reading into the options, let's find what is the slope of this graph. Okay, slope is what? What is the slope? Slope is, we know that slope is delta y by delta x. Right? So slope of a graph is delta y by delta x. Now what is delta y here? Delta y represents current. Okay, delta y represents current. Suppose at this point this is the current I, at this point this is the current V, is voltage is V, this is 0 0. So delta y means I minus 0, that is I, and delta x is voltage. Okay, so what is I by V? So last problem we have seen that V by I is equals to resistance. V by I equals to resistance. So slope in this case is 1 by resistance. Okay, V is equal to IR, you can put that value as well. V is equal to IR, so II will cancel, you will get 1 by R. So slope of this graph is 1 upon resistance. Now what is resistance? resistance is rho L by A. This is the formula for resistance. Now if you put that value over here, what you will get? Slope is area divided by rho into L. So this is the slope. Right, so if you increase the area, slope will increase. If you increase the length, slope will decrease. So slope will be less, area of the wire increase, so definitely not. So increasing the area will increase the slope. Less if the length of the wire is increased. Yes, correct. If you increase length, then slope will decrease. So this is correct option. Let's see other options as well. More if experiment is performed at higher temperature. If you perform the experiment at higher temperature, the rho value, that is the conductivity, the resistivity, will increase. So increasing the resistivity will decrease the slope. So option C is also incorrect. More if wire of the steel of same dimension is used. Now steel again has higher resistivity, so resistivity increasing means slope will be less. Okay, so the similar question might come in your exam with the different options, so you have to be prepared if the question options are changed. Now question number 21. Though the electron drift velocity is small and electron charge is very small, a conductor can carry an appreciably large current. Okay, so drift velocity, I think we have solved one problem where we have seen that the drift velocity is 1 by 6400, which is very, very small. Okay, charge of an electron is 1.6 into 10 to the power of minus 19. So if you multiply them, you might get that, okay, you might get an idea that, okay, current should be very small. But what is the expression for current? Expression for current is NEA into VD. So even though E and VD are small, because the number density of electron is very, very high, current is not appreciably low. Okay, so electron number density depends on temperature. Yes, it depends on the temperature, but let's see other options. Electron number density is very large. Yes, electron number density N is very, very large. It is of the order of 10 to the power of 28. Okay, that is why a conductor can carry current. So option B is correct. Relaxation time does not matter. Drift velocity of electron is very large. Obviously drift velocity of electron is mentioned here is very small, so definitely it is not correct option. Okay, next question. Masses of 3 wires of copper are in the ratio of 1:3:5 and their lengths are in the ratio of 5:3:1. The ratio of their electrical resistances are. So we have solved this in one of my previous classes. Let's solve it once more. So how can we solve this question? So if you want to solve it, it is a very long process. If you remember the answer, maybe it will help you to solve this question, but in the final exam, if the values are changed, you have to know how to solve it. This is little lengthy but not super difficult question. So mass of an object is basically given by its volume into its density. Okay, volume into its density. Now density I am writing as D, not conventional rho, because rho, because it is electricity, rho represents resistivity, so that's why I am not using rho over here. So density is D. Now density for a given material is constant. Okay, density for given material is constant, so changing mass means volume is different. Right, so how volume represents? Volume is basically length of the wire into its cross sectional area. That is the volume. Length into area is volume times density. Okay, now in the question it is mentioned that mass ratio of masses M1 is to M2 is to M3 is given 1:3:5. 1:3:5. Now you can use this your young generation problems where you used to use one constant of proportionality and then you 1k, 3k, 5k, or this problem what we will use, we will say that the constant is 1, the k value is 1 itself. So mass M1 is basically 1 kg, mass M2 is 3 kg and mass M3 is 5 kg. You don't need to write the units. Obviously, unit is not required. Similarly, for lengths, we also consider the lengths L1 equals to 5, L2 equals to 3, and L3 equals to 1. We will assume that, okay, constant of proportionality, we will assume that to be 1, right? Now, what is M1? M1 is equal to L1 into A1, or from here we can calculate A1 is basically 1 upon L1, that is 1 upon 5, okay, and here L2, A2, so A2 is 3 by 3, that is 1. Okay, 3 by 3, which is equals to 1. Okay, now what is M3? M3 is L3 A3, so A3 is 5 divided by 1, so it is 5. Okay, so we have calculated the areas. Now we have to find the resistance. Okay, resistance is, what is the ratio of resistance? Rho L1 by A1 plus, is to rho L2 by A2, obviously rho will cancel, is to rho L3 by A3. Rho cancels. So what is L1? L1 is 5. What is area? Area is 1 by 5, is 2. What is L2? L2 is 3. What is A2? A2 is 1, is 2. What is L3? L3 is 1. And what is A3? A3 is 5. Okay, now this 5 will go up because 1 by division of division, so it will be multiplication. So 25 is to 3 is to 1 by 5. Now again we have to multiply every one by 5, so we get 125 is to 15 is to 1. So 125 is to 15 is to 1. I know many of you remember the answer, this answer, but you have to know how to solve it quickly. So this is the way how you can solve it quickly. Okay, now next question. Again another interesting question. In the given circuit, the current through 2 ohm resistor. In the circuit, current through this 2 ohm resistor. We are trying to find current through this 2 ohm resistor. How to solve it? First we have to find the equivalent resistances. Okay, at least equivalent resistance options up to this point. Then whatever current in that branch, same current will pass through this 2 ohm, and we can solve it. First we will see that we will start with this triangle. Okay, this triangle we will start, and if you see that we have this 1 ohm and this 1 ohm are connected in series, and this combination of resistance is connected in parallel with this. One more thing. One more thing. So if you see that, so this is a short circuit. This is a short circuit, so we do not need to do anything. This is just a full problem. Okay, here as you see that this is a short circuited circuit. Okay, short circuit means no current will pass through any other any one of the resistor. This resistor no current, this resistor no current, there is no current. Okay, because current always passes through the smallest resistive path. Okay, lowest resistive path. So in this case, if you see that the smallest resistive path is this one. Okay, because if the current passes through here or through here, okay, the resistance will be more. Here there is no resistance. This is a short circuit. Okay, so current will, instead of passing through these resistances, it will directly come from here. It will pass through this, and then it will come back to this point. Okay, so this is the easiest path. Now what is the total resistance of this path? Total resistance is 1 ohm and plus 2 ohm. So total resistance is 1 plus 2, that is 3 ohm, and applied voltage is 1.2 volt. So what is the current in the circuit? Current in the circuit is V by R. that is 1.2 divided by 3, that is 0.4 volt. So it will be 4 ampere. 0.4 ampere. Correct answer will be option A. Now next question. Kirchhoff's junction rule is a reflection of, so junction rule or current rule is a reflection of conservation of charges. Okay, conservation of charges. Now the variation of terminal potential difference with current flowing through a cell is as shown. The EMF and terminal resistance of the cell are. So you have to find the EMF and internal resistance. Okay. So first of all, when there is no current in the circuit, if you can make the current zero, if you can make the current in the circuit zero, then whatever is the potential, that will give you the actual EMF. Why so? Because we know that EMF equals to V equals to terminal voltage V equals to epsilon minus IR. Now if I equals to 0, then V should be equals to epsilon, right? So this is the point where we can say that, okay, that means this is the point where I is equals to 0. I is 0 is in this point, right? So I is 0 here. That means the terminal potential is basically 3 volt. That is the EMF of the circuit. Okay, so this is the EMF of the circuit. So EMF is 3 volt. Now you have to find the internal resistance. Now when what is the terminal voltage here? Terminal voltage here, this is x-axis, right? So y should be equals x-axis means y should be 0. So terminal voltage is 0. So 0 equals to epsilon minus IR. Okay, what is the value of I in this case? I is 6 ampere. So from here epsilon minus 6 into R. Now what is R? That is equals to 0. So R equals to epsilon by 6. Epsilon is 3 volt divided by 6, that is 0.5 ohm. So the internal resistance is 0.5 ohm and the voltage is 3 volt. Okay, 3 volt here. So from this point you get the terminal EMF of the battery, and from this point you get the internal resistance of the battery. In a potentiometer experiment, the balancing point of a potentiometer is deleted. So this is not important. Wire of certain material is stretched slowly by 20%. Its new resistance and specific resistance becomes respectively. So as I said, what is the formula to calculate the new resistance if it is increased by some percentage? So I said it is basically the new resistance is 1 plus percentage divided by 100 whole square into the original resistance. Okay, so it will be 1.2 whole square into R. So 1.2 whole square is 1.44 R. So it will be 1.44 times the original value, and the specific resistance or resistivity that remains constant. So option B is correct in this case. So you might think, okay, always 1.21 will be the answer. It will not be always 1.21. Based on how much it is changing, you have to apply this formula and calculate it. If you don't want, you have to change the whatever is the new length. From there you have to calculate the corresponding area. That will be a very, very long process. This is the shortcut process. Okay, as I said, if it is twice, thrice or 4 times, you can use that number directly over here. Okay, if they say the length is doubled means R dash equals to 2 square into R. Length is tripled, then it will be 3. Length is quadrupled, then it will be 4. Okay, based on that you can find how much the resistance will change. Now if R1 and R2 respectively the filament resistance of a 200 watt bulb and 100 watt bulb designated to operate at the same voltage, then you have to find the relationship between R1 and R2. Suppose the common voltage is V. Suppose the common voltage, designated voltage is V. It can be 220 volt, it can be 200 volt. Okay, that voltage is say V. Okay, we know that power equals to V square by R. Okay, power equals to V square by R. So from there P1 by P2, or you can say that if voltage is constant, power is inversely proportional to resistance. Power is inversely proportional to resistance. So P1 by P2 equals to R2 by R1. Okay, what is the power of the first bulb? Power of the first bulb is 200. So 200 divided by 100 equals to R2 by R1. So R2 equals to 2R1. Okay, R2 equals to 2R1. Option B is correct in this case. Next question. A cell which produces an EMF of 1.5 volt is connected in series with an external resistance of 10 ohm. Okay, if the potential difference across the cell is 1.25 volt, the internal resistance of the cell in ohms. So we have a external resistance of 10 ohm and we have a cell of 1.5 volt. Okay, internal resistance is R. So current in the circuit, say I. Okay, then we know that current I is basically, what is the value of current I? Terminal voltage divided by R plus small r. Okay, this is the formula. So you can put the values. Epsilon is 1.5, R is 10, small r we don't know. Now, this problem might seem very simple. It is slightly tricky. You have to do some mathematics here. Okay, so terminal voltage is epsilon minus IR. Okay, so terminal voltage is 1.25 given, epsilon is 1.5 minus I into R. Okay, I is 1.5. Okay, there is a R over here, divided by 10 plus R. Okay, or you take it on the other side, 1.5 R by 10 plus R equals to 0.25. This will come to other side, right? Now just do the cross multiplication. So 1.5 R equals to 2.5 plus 0.25 R. Take it on the other side. So 1.25 R equals to 2.5, or R equals to 2 ohm. So internal resistance is 2 ohms. Okay, just do the mathematics step by step. You will get the answer. Now, this is another important question. The effective resistance between P and Q for the following network. So effective resistance between P and Q for the following network. So it looks like very complex, but we will start here and we will see that these two resistances are connected in series. Okay, we can draw this line without lifting our pen. So definitely they are in series. So 3 and 3 are in series. So 3 and 3, what is this addition? 3 and 3 will be 6 ohm. Now this 6 ohm will be like this, right? So this 6 ohm and this 2 6 ohms are connected in parallel. So when 2 6 ohms are connected in parallel, what is the equivalent resistance? Equivalent resistance is equals to 3 ohm. Two equal resistance, two or more equal resistances, if they are connected in parallel, then the equivalent resistance is R by N, right? R by N, one of the value of one of the resistance divided by total number of resistances. Here it is only 2, so R by 2, that is equals to 3 ohm. So now we have to complete this circuit. So 4 ohm is there, then we have calculated the central part is 3 ohm, then we have another like this. So this is P, this is Q, okay, this is 4 ohm and this is 5 ohm. So what is the total resistance? 4 plus 3 is 7, 7 plus 5 is 12. So total resistance is 12 ohm. So correct answer is 12 ohm for this question. So I hope you enjoyed today's session. All the questions we discussed are very, very important. The PDF will be available in our WhatsApp channel. The link already we have shared the link. If you want the link to be shared once more, leave a comment in the comment of the video, as well as subscribe to our WhatsApp channel. And if you have not yet subscribed to our YouTube channel, do subscribe, and I'll be back with more videos very soon. Till then, bye.